Kia ora, good afternoon everybody in my physics class and also Mr. Kumar's physics class when they get around to looking at this. Little wee video from me to top up the fact that I'm on isolation. My son has COVID and I'm almost certain to get it, so I'm in isolation. Just checking a couple of things here. I'm going to talk you through a couple of things about projectile motion. My take on it. We're going to do the key ideas, the book's take, and my take. Then my HDSD-PWM, which stands for Mr. Henderson's Handy Dandy Super Duper Projectile Motion Method, HDSD-PWM. It rolls off the tongue. How to find the maximum height of a projectile. This matters for things like human cannibals. They don't want to hit the bottom of the tent, the bottom of the roof, hit the roof. How to find the range, the distance that the projectile goes. We'll do an example. First of all, the book's got some key ideas, and they are found on page 106. There it is, and it looks like this. I took a photograph. So we've got a parabola. It is symmetrical. That matters. That wouldn't be the case if we considered air resistance, but air resistance is something that we don't bother with in year 12. We say it's negligible, and for most things it is. Also, if we did have air resistance, it would need about a stage 3 numerical integral calculus thing to solve it at university, so we don't do that. So these are the key ideas from the book. You can find them, and you can pause the video and read them yourself, so I'm not going to go over them. Moving along. Now, my key ideas. Projectile is something that is thrown. It's off the ground. It doesn't have to be in the air. It can be on the moon. So it's something that's off the ground in a uniform gravitational field, and it has a constant horizontal velocity and a constant vertical acceleration. The simplifying assumption is that we do not have air resistance. I mentioned that. Basically, it's two kinematic situation or equations at once, and I've got a template here for solving it, and I've got some ideas to give you a hand to reduce the complexity. So, Mr. Henderson's Handy Dandy Super Duper Projectile Motion Method. Two separate kinematic equations, but they both take the same amount of time. When something is finished landing vertically, it's finished traveling horizontally, and that matters. So we'll use this, use those ideas and make and use this thing. It's a little T-shape. I draw a little quick T-shape on my board, right, horizontal on one side, vertical on the other, and then the 5 things for kinematic equations in each case. And that's kind of cool. But then also draw a loop around the 2 T's because they will always have the same value. And they will be a zero acceleration horizontally and a constant vertical acceleration of g. Also, horizontally, the initial and final velocities will be the same because there's no acceleration. So use this template when doing questions. Exam booklets will not give you enough room for this. So you've got pages at the back. They give you the pages, say not enough room, refer to the back, and you can draw this up there. Use the left-hand side of the page for kinematic equations that are for horizontals, or if you might prefer, swap the 2 sides, it's okay, as long as you keep them separate. And the vertical side, vertical equations are underneath one side, and I'll show you in an example. Basically, the vertical motion gives you the hang time. Skaters and skiers know this. And the horizontal motion is the travel distance, so it's the distance to speed times time. Here's an example. Captain Kirsty is flying a search and rescue mission for a stricken yacht with Captain Fergus on board. Hello, Fergus. Kirsty wishes to drop a rescue parcel containing a life raft, food and water, plus chocolate. Fergus likes chocolate. She flies at 80 meters above the ocean at a speed of 60 meters per second. How far back from sad Captain Fergus should she release the rescue package? The rescue package so it lands by Fergus? Well, so we got this situation here. Now, I haven't drawn a picture. My apologies. It'd be a good idea to draw a picture. 80 meters up, 60 meters per second horizontally. Sad Fergus floating in the water with a broken boat, and Captain Kirsty flying in. So draw that table there. And what I do here is I start writing in what I know, what I don't know, what I'd like to know, plus what I don't care about. So I'd love to know the horizontal distance. That's the reach of the, that's how far back she has to drop the parcel from. The initial horizontal velocity is 60 meters per second, and so is the final horizontal velocity because there's no horizontal acceleration. Vertically, it's the height, which is in this case is 80 meters. Initial vertical velocity in this case, because he's in level flight, is 0. But you can have situations where there's an angled thing, something shooting up and then coming back down. Final vertical velocity, we couldn't care less. It's not a person, it's a rescue life raft, food, water, chocolate, all these things are pretty tough, can hit the water pretty hard, don't matter. Now, we start with what we would like to find out. Now, the cool thing is, the equation that has this and this, not that, and this thing together, so we can find this thing here, is that one. And it's simplified because the initial velocity vertically is 0. So it simplifies to that, which is nice. My favorite step is to swap sides. Half gt squared is d. Double both sides to get rid of the half. Gt squared is 2d. And then divide both sides by g, and then find the square root. Now we put the numbers in. 2 times 80 divided by 9.81. Well, roughly kind of sort of as an initial guess. 2 times 80 is 160. Divided by roughly 10 is 16. So it should be close to 4. And because 9.81 and 9.8 is slightly under 10, the answer should be slightly more than 4. And we get 4.04 seconds. That feels right. Put it in our chart here, and we also put it on the other side because the stuff splashes in after it's done its horizontal trip. Acceleration horizontally is 0. D is VIT plus a half AT squared. Same situation again. Now, A is 0, so I can just put 0 in there, and that term goes away, and we're left with a year 10 situation. D equals VT. 60 times 4.04, 242.4 meters. And that means Captain Kirsty has to drop the package roughly a quarter of a kilometre back from the yacht to save Fergus. Hooray for Captain Kirsty, and Fergus is very grateful and very happy. Fellas, I'll make myself some more videos down the track, drop them in here, put them on my YouTube channel, post a link to Google Classroom. I have booked the trolleys for while I'm away so that you can have access to the Google Classroom in the lessons. Or if you're at home, you can do it that way too. Cheers, everybody.